Rightio, getting towards the end here. Question 33. Solve the following trigonometric equations exactly. Cosine theta equals 1/2. And then the next one, tan x equals -1. Oh, luckily we're dealing in degrees and got to be careful a little bit about the domain. This one was -180 to 180. This one's 0 to 360. Let's start with part A, cosine theta equals 1/2. Still drawing my unit circle because it's really important that we understand the unit circle. All of the answers to your trigonometric problems lie within it, and it is your best friend in maths. All right, here we go. Cosine theta. Well, cosine's my x-coordinate as a point goes around the circumference of our unit circle. Let's make sure we know it's unit circle. There's 1 and 1 and -1. And -1 as my intercepts, definitely a unit circle now. There's cosine as my x-coordinate because, of course, if this radius is 1, that's the adjacent side, and the adjacent divided by 1 would be just cosine theta, which is that side there. So that's very good. If that's 1/2, there are 2 places on my unit circle. Obviously, there's always one in quadrant 1 for a positive value, so that's where it is. Where's the other one? Follow your x-coordinate down, and you will find in quadrant 4 there is another one. There are 2 places on the circumference of my circle that correspond to an x-coordinate or a cosine value of 1/2. So they're the 2 things I need to find. What do you need apart from your best friend in maths? You need your best friend's little buddies. That's right, the 2 special triangles that go with the unit circle. First one we've got here, 1, 2, √3. We're working in degrees, which is nice. There's 30 degrees. 60 degrees is a larger angle, so it goes opposite the larger side. Now, I want cosine to equal 1/2. Cosine is, you will remember from SOHCAHTOA, cosine is adjacent over hypotenuse. It's the ratio of the adjacent side divided by the hypotenuse in a right angle triangle. So if I want the adjacent side to be 1, the hypotenuse to be 2, that must mean that 60 degrees is the angle, because that's going to make the 1 adjacent rather than 30, which is opposite the 1. So 60 degrees is my reference angle. There's 60 degrees there, 60 degrees here. I want the values between 0 and 360. Theta is going to equal either 60 degrees or 360 minus 60 is, of course, 300 degrees. And you're done. Not too bad, is it? Tan x equals -1. Well, let's get our unit circle, and we're going to work with the same circle again, because why not? Whoa, well, we were going to, except I deleted too much. Let's get it back and see if I can be less uncoordinated. Well, slightly less uncoordinated. I think I've got more luck putting the axis back in than I do the circle. There we go. Now, the tangent axis, there are 2 places I could draw it, but I think this is the one that I've had the most success with students understanding. So I'm going to stick with tan. That's my tangent axis. So it is at a tangent to the circle. Surprise, surprise. If tan x is -1, it's got the same scale as the y-axis here where we read the sine values from. So obviously it's going to be +1 at that point, -1 at the same place as -1 on the sine axis. So 1 up there, -1 down there. If I want the values that give me tan equaling -1, all I do is I draw a line back from that -1 point through my unit circle. And so there must be 1 point on the circumference of a circle there and 1 point there. So in quadrant 2 and quadrant 4. Now, I didn't mention this before, but no doubt your teachers have already mentioned to you the all stations to central or cast rule. I like to go with the A first, so that it's in quadrant 1, so we make sure we get it in the right place. I remember tangent as where it touches the tangent axis, which is, I think, the most logical way to think about it. But also you can just say, well, tan is negative, so I'm in quadrant 2 and quadrant 4. If that's the way you do it, that's okay. It still works fine. There is nothing wrong with that, as Gormsby would say. Is that the right pen? How thick's that going to be? Oh, let's just find out. It looks like it'll be pretty thick, but that's okay. So, tan x equaling -1. That seems to ring a bell, but it doesn't come from this triangle. Would it come from my other special triangle where I have 1, 1 and √2? 45 degrees, 45 degrees. Well, tan of 45 is 1 over 1. That would be 1, wouldn't it? So the reference angle, how far from the x-axis this is 45 degrees. And again, the reference angle, the distance from the x-axis is 45. Now I'm going from negative 180 to 180. So negative 180, instead of starting at 0 degrees here, I start at negative 180. So I want to know this. This will be a negative value. So x would equal, the reference angle is 45, so it would be negative 45 degrees. That would be the first one. And then I keep going around until I'm 45 degrees short of 180, which is, of course, 135 degrees. And there you have your particular values. I hope that helps. Catch you in the next question. Bye.